at doing a proof here, see if this helps. Certainly email me if you have any other questions. So I'm here on part C, and it's part C. I don't know if it says it here anywhere, but it's 8.2. So we're going to have problems that will probably require us to use both the implicational rules from 8.1 and some of the equivalence rules from 8.2, but probably is not going to require us to use anything from 8.3 yet. But this is basically just to do a demonstration of how to do a proof. So start with a really simple one. Pardon me. Alright, let's look at this one right here. Now remember, the idea of a proof is the same thing as what you did in geometry class. So we're going to work our way step by step. We would write something out beside each of these lines. And eventually, we want to be able to get to the conclusion. In this case, the conclusion is not F. Now in each line, you will both state something and then you will cite a rule that basically gives you permission to say what you said in that line. To put it better, it shows that the rule would show that what you said in that line must be true given the lines that you cited. So for instance, we might say A follows from line 1 by rule of modus tollens. This is just an example. Essentially what we're saying is line 1 and the rule modus tollens guarantees that A must be true. So if we're doing that every step along the way, and if eventually we can write not F and cite some line in some rule, we can basically say that not F must be true based on these things. Well, if that's based on this, and that's based on this, and that's based on this, and eventually that's based on this, then essentially we've shown this, that if these are true, this has to be true as well. And that just by definition is validity. So we prove through this step-by-step process that the argument is valid, if we succeed. Alright, so let's go up here and start working on the proof. So what we want to do here is use the rules. We have to use the rules. And so it requires having them pretty well memorized to be able to see them in action here. So do you see a rule that can be used? Well, notice that this is a conditional statement. We have several rules that turn on conditional statements. Modus ponens and modus tollens are the most obvious. And in the textbook it tells us that if you have something of the form if P then Q, and you have not Q, then you can say not P. That's the rule of modus tollens. Do we have something like that? Well, we have something close. Here's our conditional statement. So this would be P arrow Q. Remember, everything after the arrow, it doesn't matter if it's big or small, follows this form. Here's G. What we really need was not G. But all we have is G. Now hopefully you're already thinking, well, it's easy. We can get not G by double negation. And you're exactly right. So I'm going to first say not G from line 2 by rule of double negation. And now that we have this, we can do modus tollens and say not F from lines 3 and 1 modus tollens. Because now we've got the negation of our consequent. Here's our consequent, and we've got the negation of it. So we're following this pattern. Antecedent, arrow, consequent, a negation of the consequent, therefore we can negate the antecedent, and that's exactly what we've done in lines 1 and 3. And maybe you're thinking, well, why couldn't I just have gone from line 2? Well, the proving process in logic is absolutely rigorous. We don't make even the smallest move unless we're justified in doing so. And we just don't have a rule that allows us to make that move, but we do have a rule that allows us to make the move we made following the modus tollens pattern. So let's go ahead and back this up. We'll check our proof, and we'll see that we did it correctly. Alright, let's go do another one. Let's look at this one now. Same idea here. We just want to go step by step through the process to get to the conclusion. Now this one is a disjunction. This is the main operator of premise 1. So we do have some rules that use disjunctions. For instance, we have from our book one that says if you have P or Q and you have not P, you can assert Q. So you might already be thinking, well, is that going to get us to the conclusion? Well, that's a good way to be thinking. But right now I'm just talking about what can we do? What's something that works? Now notice, this would be our first disjunct, and this is our second. So this now serves as P, this serves as Q, and we have not A. Now that's like a negation of part of the first disjunct here, but it's not. What would a true negation of that first disjunct be? It would have to be not A or B. That would be a negation of the first disjunct. So we can't skip ahead here, but is there a way to get something like that given just not A? Well, what if we use the rule of addition? We said not A or B. That would come from line 1 and addition. Now notice, this is close, but it's not the same thing as this. Is there a way to get from 3 to what we want here in line 4? Well, we don't have an immediate rule to get us there, so let's think about this some more. Okay, notice this disjunction is made up of two disjunctions. We have a rule that allows you to move parentheses when the two operations are the same. So let's try that. What if we went to A or B or C by rule, or from line 1 by rule of association? Now we're getting somewhere. Now notice the main operator is now this one. So if we could negate this, and we can, then we could say B or C. Because notice we're following this pattern down here. This is now the main operator, so we have P or Q. Here's our not P, so we're going to assert Q. Notice it's following this pattern. So this comes from lines 2 and 4, disjunctive syllogism. Now this is really close. In fact, it's logically equivalent to the conclusion, but it's not the conclusion. So we're not done until we have it exactly the same. Is there a rule that would allow us to just flip this around? Yes. So from line 5, by rule of commutation, we can assert that. So let's get rid of that extra stuff and let's check our proof. Oh, I made a mistake. Where did I make a mistake? So addition allows us to create a disjunction using well-formed formula from a previous line. Oh, I cited the wrong line. There we go. Hopefully you caught that even before I checked the proof. If you did, good job. Now you might be thinking, well, this line 3 didn't do anything for us. We didn't end up using it. You're exactly right. But that's okay. A successful proof is any proof where all of the steps are justified by previous lines and a rule and applied accurately, and one that ends up getting to the conclusion. Some successful proofs can be done very quickly. Some successful proofs are done in a lot of steps. It's nice to do them as efficiently as possible, but it doesn't make them any less proven if they're done in a longer route. So this is a successful proof. We put this line in, which was an accurate application of the rule. We just didn't happen to need it. All right. I wanted to go ahead and do this one, because this is one where you really have to start thinking in terms of the rule patterns. Even though there's a lot of operations going on here, this is just a disjunction. So this is our, if in the pattern P or Q, this is our P, this is our Q, and we could work through it from here. This video is getting a little long, so I'm going to go ahead and leave this with you. If you'd like for me to work this one out with you, email me as well. If there's any other specific questions, certainly email those to me, and we can talk about that. Hope all goes well.